So your application has a user DB where you store certain user information, and since you're a responsible developer, you are not storing passwords in a plain text format, you are hashing them. And you're hashing with an algorithm like MD5 or SHA. And you feel like you've done the right thing, but it's kind of a trap. If your database is breached, and you should always assume that it will be breached, using a simple hash is game over. Let me tell you why. So when hackers breach your DB, they get a copy of your table where you're storing information like password hash, or right, they get a copy. Let's assume there are two users, Alice and Bob, and they have the exact same password and hence the password hash. This kind of is the flaw of simple hashing. The same password always produces the same hash. So hackers don't try to reverse this hash one by one. That's the catch. They don't do this reversing, right? That's too slow. They use a weapon called a rainbow table. They've already done the work for millions of common passwords, right? Now they just take the hash from your DB, look it up in their rainbow table, and instantly get the original password. For users like Alice and Bob, it's game over in a fraction of seconds. So what do? How do we defend against this? Our first line of defense is simple but a powerful concept called a salt, right? A salt is a unique random string that you generate for every single user and store within your user table. So now you don't just hash the password, you hash the password plus the salt. So even though Alice and Bob use the same password, like a password 123, their unique salts mean that they now have a completely different hash. So suddenly that giant rainbow table is now completely useless. The hash in your DB don't exist in their pre-computed list, right? You have successfully defended the mass attack, right? But are we done? Not really. The hacker still has the table. They have Alice's username, the hash, and the salt. Now they can launch a targeted attack. So understand this. Modern GPUs are really fast. They can test billions of password combinations per second against a user's hash. Because algorithms like MD5 and SHA are designed for speed, a moderately complex password can still be cracked in minutes. So this brings us to the real solution and our final magic thing, which is a key derivation functions, or called KDFs, right? You might know them by names like bcrypt or scrypt, right? So unlike MD5, what happens is these algorithms are designed to be deliberately slow. They have a configurable setting called a cost or work factor, right? Cost or work factor, etc. This forces the server to perform thousands of rounds of calculation for a single hash. So for a user logging in, this might take like 100 milliseconds, but they will never notice. But for the attacker, this is a nightmare. Their GPU, which could try billions of fast hashes per second. When I say fast hash, it's like MD5 or SHA. If they guess now with a KDF, like reverse the KDF, they can maybe try 10 guesses per second, because it's a slow, like it takes 100 milliseconds for a single hash. This is computationally expensive and time consuming, and hackers will simply just move on to probably a easier target.